Hello, welcome to Train Talk. I'm Monty.
I'm Rebecca.
And Rebecca, we have a special treat. We are going to be going audio only today. So we're interviewing Siv from Texas Central. We're going to be doing that only on audio. If you didn't know, if you haven't followed us on any other platform other than YouTube, this podcast is available on iTunes, Spotify, wherever you download your podcast. So
yeah, and that's a really exciting thing for those of you who love learning about trains but don't necessarily like looking at our faces. This is your opportunity to do that.
Let's go to audio only, Rebecca. Today we're talking to a really cool guy. We're talking to Siv Bhamra, who is a integration director for the Texas high-speed train. He's worked on many train systems before, and we're really excited to have him on this project and on our podcast today. Siv, how are you?
Great. Welcome. Good to be here, and a great opportunity to talk to yourselves.
So, Siv, tell us a little bit about what an integration director does.
So basically, it's about bringing all of the sum of the parts together with the aim so that at the end of which we've got a dedicated a train solution, basically something that meets what our sponsors have asked for and something that works safely and reliably in passenger service.
Okay, well, before we get into how that works for the Texas Central high-speed train, can you tell us a little bit about your background? Where were you before Texas Central? I detect a little bit of an accent. Have you? Where were you previously?
So basically, I've worked all over the world, and I've spent 30-odd years in rail projects internationally. This is my fourth high-speed rail project, so a lot of experience in this area. I've got a few degrees in the days when I guess they were easier to get by, and a few titles again in the days when they were easier to get by.
So I know your educational experience in this field is vast. Can you describe for the viewers at home what your educational background is?
So I've got a bachelor's degree in engineering, in electrical engineering, a master's degree in systems design, an MBA in project management, and a PhD in railway systems engineering, which is very similar to the needs of this job.
So is it safe to say then you are an expert?
We're always learning.
Spoken like a true expert. So I know one of the key components in the design and engineering of this project is revolves around purpose-built infrastructure. Can you talk to us a little bit about what that means?
So basically, in a project like this, where you're going to run trains at 200 miles per hour, what you're required is basically a dedicated infrastructure, what we call in the technical terms a dedicated guideway. In other words, you've got specifically designed trains to meet a dedicated infrastructure, so that you get maximum and safe performance between two defined distances or two defined cities, and that requires precision engineering. And it requires a great deal of thought. And when everything comes together, the success is phenomenal.
So what are the main challenges then as an engineer that you face with building a high-speed rail corridor?
So basically, we've got to build it in a manner which is sustainable, which meets the needs of the communities, and it also meets the needs of the customers of the future, not just day one after opening, but for decades and decades ahead of time. And so as a result, thinking now will provide a lot of benefits in the future.
So how does your experience on other trains in other countries differ from what's expected of you, and how you're integrating the Texas train into the Texas economy?
So basically, I suppose some of the benefits of having worked before is you've built projects, high-speed rail projects in Asia and in Europe, where there's a lot more acceptance and a lot more trial and a lot more experience around. Here in the US, the experience is that much more limited. So as a result, the additional challenge is to be bringing a technology which is new to the US, and also a set of skills, which are new to the US, which is quite exciting, by the way, in itself, as well as a challenge. It's a great opportunity to do something unique.
It's a new industry, a completely new industry in not only Texas, but the whole United States.
Correct, yeah. And to bring an advanced technology like high-speed rail or high-speed train to the US environment, the world's most advanced economy, is quite an exciting thing to do.
So having worked on so many high-speed train projects and having such a depth of experience and education within high-speed rail world, what is your familiarity with the Shinkansen system and how does it differ versus other high-speed train technologies?
So all high-speed train technologies have a proven product. I mean, they're all capable and they're all safe and they all operate well all over the world. What sets Shinkansen apart is what I always say is even when it emerged in service in 1964, it took the world by surprise. It was a good 2 decades ahead of its time compared to the rest of the world. And a lot of countries try to catch up. What's unique about Shinkansen is its phenomenal safety record. Since passenger operations in 1964 started, the safety record is phenomenal. Historically, it's great. Who knows what the future will be? But historically, this is one hell of a system. Arguably the safest transportation system in the world. And that makes it unique. It's also very reliable. I mean, close to 100% of punctuality of trains, of timetable trains reaching their defined destinations.
So let me stop you there. You said 100%, nearly 100% of timetable, like reaching its destination when it's supposed to be there.
Correct.
So
I believe I even saw an article from BBC about a year ago that when one of these trains operating in Japan left the station about 20 seconds too early, the company operating at JR Central actually issued a formal apology to its riders. Is that something that you experience here when you're delayed in traffic behind the construction crew?
No, it's not. I can't even fathom really the reliability of a system that could get you from Dallas to Houston in 90 minutes every time on time. I mean, if you've flown Dallas to Houston, there are cancellations almost every day. There are delays. You'll be taxiing on the runway for 2 hours. Driving, everybody knows the trouble with driving. You may be there in 3.5 hours. You may be there in 5.5 hours. The reliability to be able to say, all right, I have a train at noon and it's going to be there at 1:30 every time. There is nothing in the United States that even comes close to that kind of reliability to get you 240 miles per hour like that every time. That's a really
205 miles per hour.
240 miles at 205 miles per hour. Thank you, Rebecca.
You're welcome.
Yeah, but
here to fact check all day.
But yeah, no, I just really wanted to harp on that for a second because that's my favorite part. That one's just a really, really incredible track record.
It is. That's amazing to think 99.5% is a figure used of the number of trains which were timetabled to arrive on a specific period do so, which is like, well, what can we say? It's about 1 train in 200 that actually misses its timetabled arrival, which is enormous. It's just phenomenal. It's exciting, isn't it?
It's probably by seconds or maybe a minute or two.
Correct.
That they miss. Yeah.
And it's just incredible, isn't it?
It is. It's amazing.
So these trains, you said, took the world by storm back in 1964. Are we going to be bringing the train that was operational in 1964 to Texas?
Not exactly the same train and not exactly the same technology, but it's effectively an adaptation of what was and has been a truly successful operational model. And what we do, like I said, in engineering, in an integrated approach, is our whole focus is on delivering service excellence as an output. So what we do is through the integration effort is to make sure that what we build is collectively safe, collectively operable, collectively maintainable, and performs to the world-class standards that we're setting out for.
So I saw in the news about a year ago that JRC has unveiled their 6th generation of Shinkansen technology, the N700S, S standing for Supreme. Do you have any thoughts about that latest generation?
That's phenomenal because it's lighter, it's more energy efficient. It's also environmentally more efficient, meaning that it provides less spread of noise. So it's good for, as well as the passengers riding on the trains, it's good for any staff that may be nearby. And it's also very good for the local communities as well. So it's much more sustainable to the environment. The previous versions were very sustainable as well. I mean, this just takes it to another level. And that in itself, it pushes the boundaries of what is possible in engineering and in technology that much further. And that's great to be a part of. And it's great to know that that particular technology will be here in Texas before too long.
I mean, it's almost as if this entire project is a real life TED Talk. It's talking about, establishing something brand new, creating an entirely new industry here in Texas and the United States, utilizing cutting edge innovation of 54 years and counting of continuous innovation and improvement on a system like this. How exciting is it for you to be able to work on a project like this that's the first of its kind?
Oh, it's absolutely phenomenal. I mean, when projects like these initiated for the first time around the world, and to be part of that, I remember getting mentored, by really, really great engineers, and you learn. And then after you've seen the solution actually being developed, to come over and to implement something, knowing how it's going to change things and shape things for the better here is enormous. There'll be great legacy here. There'll be local economy boosts, of course, within the cities and in the counties, but also for the state. And nationally, it creates a skill set and legacy, which is not just creates wealth here, but it creates export potential for the US as well.
Well, speaking of that, what do you see for the future of high-speed trains in Texas, in the United States, and beyond? I mean, do you see that? Do you see a future for other high-speed trains in the U.S.?
Indeed, so I think the U.S. Economy is set right for something like this. I think the use of cars and everything isn't sustainable in the very long term. So whether it's this generation or the generation after, certainly the trains are coming. The trains came to Europe. The trains came to the Far East, and they're rapidly even expanding high-speed rail technology in the Middle East as well. I mean, Saudi Arabia now has an application, and there's a great deal of interest all over the world. So the US is following a path which is proven and which is safe and which is reliable, and it's good for the environment, which is good.
So can you talk to us a little bit about the environmental component of the benefits that a high-speed train bring over, say, driving on an interstate highway?
I mean, typically for emissions, for instance, it could be 9% of the emissions of a plane carrying the same number of passengers. And similarly, on a same lane of motorways, for instance, or highways, the number of cars involved, it could be up to 15 to 20 times, more environmentally efficient compared to the number of passengers it packed inside of the car.
Yeah, not to mention that it's in a lot smaller space that those passengers are packed into, rather than big, giant, wide highways. There's one narrow strip of track, basically from Dallas to Houston, where you can get that many people. You can move that many people.
Yeah, and like I often say, I mean, the safety is not just the safety of the train itself. The safety is the amount of risk that we remove from our roads. Every day when somebody takes a car out, there's a judgment, there's a human judgment in that car moving, and then there's passengers involved, and there's risk associated with it. So for each driver that is taking one or two passengers driving up and down from Dallas to Houston, they are basically carrying or importing a level of risk on that route. If we use advanced automatic train control technology, computerized technology, which is highly proven and safe, and we've got one driver that's carrying so many passengers, that's all that risk and all that safety liability, which we've suddenly taken away, which is great.
So you mentioned automatic train control. Can you explain exactly the difference between automatic train control versus the other ways trains are operated in the U.S. and other places?
So basically, this form of train control will always have a driver. So it's not as if the technology is available around the world where you can operate trains without people, without drivers. Yeah, but here we will have a driver on board. That's fundamental. It's important that the driver has a level of control, but more importantly, during any emergencies or any needs of the passengers, and in any abnormal operational conditions, the driver is always available. And that is another added investment, which over and above the technologies, there is always a dedicated human being which is supervising the operation of the trains, and also supervising the equipment, and providing a level of comfort for customers as well.
It's an extra level above just a typical automatic train.
Correct.
System.
Correct. Yeah. And that's good, and And in order to design the driver back in is very important, because the drivers are highly trained, they're highly skilled, highly competent in what they're doing. And what we'll do is we'll be constantly measuring their performance and training and their motivations, so that they continue to service customers not just on day one, but in 10, 20, 30, 50, maybe 100 years on as well.
That's so exciting to be able to build a system that you know is going to have the longevity that is essentially a 100-year piece of infrastructure that's going to outlive all of us.
That's phenomenal. Can you imagine we create an infrastructure knowing that it will serve travelers for generations to come? It'll be a legacy which will succeed ourselves, and it's something that we've created, and that creation will inspire others as well to build the similar arrangements all throughout the United States.
Yeah, I believe the current estimate is we're going to have about 10,000 people per year to construct the project for the 4-year construction period, and then 1,500 or so when it's in full operation, and that's along the entire alignment, maintenance facilities where we'll be performing maintenance every night. And is that about right? Does that?
Yeah.
Yeah.
And again, just imagine that jobs that don't exist today, we will create jobs. And we're not just creating jobs for the sake of creating jobs. We're creating jobs that will provide high-tech positions, which will also generate income, not just provide social benefit and revenue benefits, but will also provide tax revenues and incomes. And those people with those skill sets can build similar systems all around the United States. And also, those people can go back across the world and export those skills and technologies. Again, very good for Texas and for the United States.
So currently today, I can't go get a degree in high-speed train engineering, mostly because I'm really bad at math. Do you foresee in the future someone being able to get a degree in specialization within the high-speed train sector here in the United States?
I believe so, of course. I think once we've started generating a level of interest, and then we've got an industry which needs to be supported, we will be establishing schools of technical excellence, as we call it, So we'll be building engineers of the future, excellent engineers of the future, and excellent operators of the future as well. Not only will we match the best of the airlines, I genuinely believe that in 5, 6, 7 years from now, we will be beating the best of the airlines using the Shinkansen excellence that exists today.
That's incredible. I think it's really impressive that we have this it's local here in Texas project that's going to have that global influence and that the national and global influence, and I can't wait to see how all that unfolds.
So you've seen systems like these develop all over the world, studied them extensively. What kinds of social and economic benefits do you see this project bringing to Texas?
So basically, there's one obviously of safety, which is and reliability, and the other one is social and economic type of benefits. It's also very sustainable for the environment. And like we say, as far as the economics are concerned, it's both the national and state benefits, economic benefits. Now, over distances from between, say, 1.5-hour journeys through to 4.5-hour journeys, all over the world, high-speed trains have shown to have taken the market share away from road and from the airlines as well. And that's been quite significant shifts. It's happened in the Far East, and it's also happened in Europe as well.
And DFW to Houston is about 243 miles, if I'm correct?
Correct, yeah. So that's a sweet spot. It's a sweet spot which, in a journey time, like I said, between an hour and a half, total journey time, be it by car, be it by plane, out towards 4.5 hours. Once you get beyond 5 hours, the plane tends to be the pick. You're better off using the plane. If the journey time is less than an hour, it's probably more convenient to drive anyway, or to use a DART or another form of public transport, the bus or something. But certainly when your journey times are between 1.5 and 4.5 hours, then the train, high-speed train, is a mode of choice.
Well, we're really excited to have this be the mode of choice for people traveling between North Texas and Houston. What would you say, in your experience again, is one of the biggest challenges to building this system here in Texas?
I think you'll be building really it's a skill needs. I mean, the environment in Texas is ideal in terms of building a high-speed line. And we don't have added complications of building tunnels or anything complicated.
No blasting through mountains.
That's right, yeah. It's a relatively straightforward terrain, you know, and the technology is proven for this kind of an environment, is built for an environment like this. It's ideal. I think the challenge will be how quickly we can upskill, you know, the key people here, the communities here, and how quickly we can provide people with the skills and the knowledge in order to build this as quickly as we'd like to.
All right. Well, Siv, thank you so much. I've learned a great deal. Please join us again. Thank you, everybody, for watching. I really have no idea how to end these things, so I'm just going to throw it back to Siv. Siv?
Thank you. The ending will be basically service operational excellence is what we're always looking at. So that's the integration effort. Thank you for the opportunity to talk.
Yep. All right.
Integration excellence.
That's right.
All right. Thank you. Thank you, Siv. Thank you, everybody.